Hello everyone, welcome to the fourth video of Ionic equilibria. In the previous video we have spoken about the pH of strong acids. In today's video we are going to cover how to calculate the pH of weak acid and pH of bases. So I am Arpita Banerjee and you are watching Arpita classes. Let's get started. Your first question is, find the pH of a weak acid. Find the pH of a weak acid HA. The concentration is given 8 molar and Ka of this acid is given 2 into 10 raised to power minus 8. So for a weak acid we already know Ostwald dilution law. We have derived that. So let us see how this weak acid dissociates. Now since it is weak acid, it will partially dissociate to give you H plus and A minus. From 1 mole of HA, we are getting 1 mole of H plus. So from 8 molar, this is the initial concentration, okay? We will not get 8 molar because it will not completely dissociate. Initially, when 8 molar of HA is there, this is 0, this is 0. Let us consider the degree of dissociation is alpha. So, alpha degree of dissociation means from 1 mole, alpha dissociates. So, from 8 mole, 8 alpha dissociates. So, what is the concentration at equilibrium? What is the concentration of HA at equilibrium? It was 8. 8 alpha got dissociated. So the concentration at equilibrium is 8 minus 8 alpha. So from 1 mole of H plus is formed. So when 8 alpha is dissociated, 8 alpha of H plus is formed, 8 alpha of A minus is formed. Now we will write down the ionization constant of an acid. The expression for ionization constant of an acid is concentration of H plus, concentration of A minus divided by concentration of HA. We have the concentration, put it here. This is 8 alpha into 8 alpha divided by 8 minus 8 alpha. So here you are getting 64 alpha square. 8 is common, 1 minus alpha. This is getting cancelled. So you are getting 8 alpha squared. So 2 into 10 raised to power minus 8, which is the value given for 8 Ka, is equal to, we are getting 8 alpha square. 1 minus alpha will be neglected. So 2 into 10 raised to power minus 8 is equal to 8 alpha square. Therefore, alpha square is equal to 2 into 10 raised to power minus 8 divided by 8. This is coming 1 by 4. 1 by 4 is 0.25 into 10 raised to power minus 8. 0.25 can be written as 25 upon 100. That 100 will go up, so it will be 25 into 10 raised to power minus 10. This is the value of alpha square. Therefore, alpha would be is equal to, I'll do it here. Alpha will be is equal to square root of 25 into 10 raised to power minus 10, which is 5 into 10 raised to power minus 5. This is the value of alpha we got. Okay. We need to find out the pH. For that, we need H plus ion concentration. So the H plus ion concentration is 8 into alpha. Put the value of alpha, 5 into 10 raised to power minus 5. So it's coming 40 into 10 raised to power minus 5, which will be 4 into 10 raised to power minus 4. So this is the H plus ion concentration we got. Now let us see the pH of this solution. I'll do it here. pH of the solution will be minus log of H plus ion concentration. Now for this solution, this is to the base 10. H plus ion concentration is coming 4 into 10 raised to power minus 4. So let us calculate this. Minus log 4 to the base 10 minus of log 10 raised to power minus 4. So it's coming minus log 2 raised to power 2 we can write for log 4 minus of minus 4 log 10 to the base 10. So it is minus 2 log 2 plus 4 minus 2 into the value of log 2 is 0.3 plus 4. So it's 4 minus 0.6. 4 minus 0.6. So the value will be 3.4. So pH of this particular solution is coming 3.4. So this way we can calculate the pH of a weak acid. Let us summarize it again one more time. We have been given that we have to find out the pH of a weak acid HA whose Ka is given to us. So first we'll see the dissociation of HA. HA dissociates as H plus and A minus. Initially we will consider there are 8 molar of HA. So this is 0, this is 0. Alpha is the degree of dissociation. Degree of dissociation means from 1 mole alpha gets dissociated. So from 8 molar, 8 alpha will get dissociated. So at equilibrium, the concentration of HA which remains is 8 minus 8 alpha. And now from 1 mole of H plus is formed. So if 8 alpha dissociates, 8 alpha of this H plus will be formed, 8 alpha of A minus will be formed. So from here we are getting the expression for Ka, which is concentration of H plus into concentration of A minus upon concentration of Ha. We are putting all the concentration values, calculating, neglecting 1 minus alpha because alpha is very less as compared to 1. So we are getting alpha is equal to 5 into 10 raised to power minus 5. This is the value for alpha. Now we are calculating H plus, which is 8 alpha. So 8 into this value, which is giving you this. Now finally we come to pH, which is minus logarithm to the base 10 of H plus ion concentration you are putting, and then you are calculating the value for pH of this particular solution. Please copy down. Let us see the next question. We need to find out the pH of 0.002 normal acetic acid, which is 2% dissociated. First of all, here the concentration is given in normality. I told you for the calculation of pH, we have to always get the concentration in molarity. So first of all, we have to convert the concentration into molarity. Secondly, it is given 2% dissociated, means the value of alpha is given here. Okay, let us say our acid is acetic acid, CH3COOH, which is a weak acid. So it will dissociate to give you CH3COO minus and H plus. Consider initially we have C molar acetic acid. So this is 0, this is 0. Alpha is the degree of dissociation. So at equilibrium, this will remain C minus C alpha. This will be formed C alpha and this will be formed C alpha. From here we can get the equilibrium constant. But before that, let us convert the normality into molarity. We have the relationship N is equal to M into X. This is 0.002 molarity into X. X for acetic acid is 1. It is just liberating only 1 H plus. So this is 1. So even the molarity is 0.002 molar. So we do not have any problem in this. Now, Ka is equal to concentration of CH3COO minus concentration of H plus divided by concentration of CH3COOH. Let us put all the concentration. This is C alpha into C alpha divided by C minus C alpha. So here it is C square alpha square divided by C common 1 minus alpha. C and C square gets cancelled. So it is only C alpha square. 1 minus alpha we will neglect. So the value of Ka is coming C into alpha square, and alpha square, the value of alpha is given. Okay, so we have to actually find out pH. So for pH we need only H plus ion concentration. So what is H plus ion concentration? H plus ion concentration is C into alpha. We actually do not need this. We need pH. For pH we need H plus ion concentration, and that is C alpha. C is 0.002 molar and alpha is 2%. 2% meaning is 2 upon 100. So basically we are getting this is 2 upon 1000 into 2 upon 100. So it is coming 4 into 10 raised to power minus 5. This is the value of H plus ion concentration. Now from here we can find out the pH. We do not need this basically, so I can just rub it Okay, so we need the pH. pH is equal to minus logarithm of H plus ion concentration, and for this particular solution H plus ion concentration is coming 4 into 10 raised to power minus 5. So calculate this, minus log 4 minus log 10 raised to power minus 5. So this, for log 4 we can write 2 raised to power 2 minus of minus 5 log 10 to the base 10. This is minus 2 log 2 plus 5. This is minus 2 into log 2 is 0.3 plus 5. So it is 5 minus 0.6. The value is coming 5 minus 0.6. So 5 minus 0.6 is your 4.4. So pH of this solution is coming 4.4. So here I showed you two things. That is, first is the molarity, the concentration is given in normality, so that you need to convert into molarity, because in the calculation of pH the concentration has to be in molarity. Secondly, we do not need the value of Ka because alpha is given to us, so we will just see the concentration of H plus ion concentration from here. So we are getting H plus ion concentration and then we are finding out the pH of this solution. Let us now start with pH of a base. How to find out the pH of a base? Before going to the numericals, we will be doing one derivation out here. That is, at 298 Kelvin, pH plus pOH of any solution is 14. This particular thing we have to derive. At 298 Kelvin, pH plus pOH is equal to 40. Now let us start from ionic product of water. What is ionic product of water? Kw, and the value for Kw is concentration of H plus into concentration of OH minus. Since we are so Kw is equal to concentration of H plus into concentration of H minus. Now take log both sides. So log to the base 10 Kw is equal to log to the base 10 concentration of H plus into concentration of OH minus. Now here log A into B, which is going to give you log of A plus log of B. Okay, so we got log Kw is equal to log H plus log OH minus. Now take negative sign everywhere. So multiply by negative sign. Log to the base 10 Kw is equal to log to the base 10 H plus log to the base 10. Sorry, this also will be minus, plus minus minus. We are multiplying by minus sign. Okay, so this will be, now since log to the base 10 H plus is pH, similarly log to the base 10 Kw is called as pKw. Okay, so pKw is equal to, we get pH plus pOH. This is one thing we got. Secondly, you can put the value of Kw. Log to the base 10 raised to power minus 14 is the value of Kw at 298 Kelvin. This is your pH and this is your pOH. Now here it is minus of minus 14 log 10 to the base 10 is equal to pH plus pOH, or we get 14 is equal to pH plus pOH. So see what we wanted to derive, we got that. pH plus pOH is equal to 14 and pH plus pOH is equal to pKw. This particular derivation we need to remember before doing the pH of a base. Now let's start with a numerical where we have to find out pH of a strong base. Here we have a numerical where we have to find out the pH of a strong base 0.1 molar NaOH. So first of all we are going to see NaOH will dissociate as Na plus and OH minus. Since it is a strong base, it will completely dissociate. From 1 molar we get 1 molar OH minus. So from 0.1 molar we will get 0.1 molar OH minus. Here we have to find out the concentration of OH minus. Okay. So the concentration of OH minus is equal to 0.1 molar. So pOH will be minus logarithm of OH minus concentration, which is minus logarithm of This is actually 10 raised to power minus 1 molar. You can write it down. So OH minus concentration is 10 raised to power minus 1 molar. So POH is equal to 1. We know pH plus POH is equal to 14. If nothing is given, nothing about the temperature, we have to by default consider the temperature is 298, and for 298 Kelvin only this expression is valid. If the temperature is given, then we have to do something else, but normally the temperature is not given and we have to by default consider the temperature is 298 Kelvin. Okay, so now put it here, pH plus 1 is equal to 14. Therefore, pH is equal to 14 minus 1. The value for pH is equal to 13. It is a basic solution, so the pH will be more than 7, and since it is a very strong base, you can see the pH is coming 13, which is quite high. Let's solve another numerical. Find the pH of 0.05 molar barium hydroxide. This is also called baryta. It's a strong base. So let us see how it dissociates. Barium hydroxide dissociates to give you barium 2 plus 2OH minus. So we can see from 1 molar barium hydroxide we get 2 molar OH minus. Therefore from 0.05 molar we'll get 2 into 0.05 molar of OH minus. So here the OH minus concentration is 2 into 0.05 molar. Multiply this, how much it is coming? 2 into, so this is actually, if I write it, 2 into 5 upon 100. So that is 10 upon 100, and 10 upon 100 means 10 raised to power minus 1. So 10 raised to power minus 1 molar is the concentration for OH minus. So now POH is equal to minus logarithm of OH minus concentration, which is minus logarithm to the base 10 raised to power minus 1, which is coming 1. Therefore, pH plus POH is equal to 14. pH plus 1 is equal to 14. Therefore, pH is coming 14 minus 1, that is 13. So, always remember the basic things which I told you, that from this is a diacetic base now. So, from 1 mole we are getting 2 OH minus. So, from this much mole we are getting 2 into the concentration. This particular things you need to remember. One more numerical. We need to find out the pH of 10 raised to power minus 8 molar NaOH. So let's see how NaOH dissociates. It dissociates to give you Na plus and OH minus. Since it is a strong base, it will completely dissociate. From 1 molar NaOH, we get 1 molar OH minus. Therefore, from 10 raised to power minus 8 molar, we'll get 10 raised to power minus 8 molar OH minus. POH is equal to minus logarithm to the base 10 OH minus concentration, and here the OH minus concentration is 10 raised to power minus 8, so it's coming minus 8 log to the base 10, so it's coming 8. Therefore pH plus POH is equal to 14. pH plus 8 is equal to 14, and pH is coming 14 minus 8, that is 6. pH for a strongly basic solution is coming 6, which is not possible because for basic solutions we know the pH has to be greater than 7. So what went wrong over here? Now see, this NaOH will not dissociate on its own. It will dissociate only in presence of water. And when you talk about 10 raised to power minus 8 molar NaOH, it is a very, very dilute solution. So from water also OH minus ion will come. So you have to consider the contribution given by water here as well. That means NaOH is dissociating to give you Na plus and OH minus. From here 10 raised to power minus 8 molar NaOH is there. So we are getting 10 raised to power minus 8 molar of OH minus. But water is also there in the solution which is dissociating as H plus and OH minus. And water, you know that when it is neutral, it gives you 10 raised to power minus 7 molar of H plus and 10 raised to power minus 7 molar of OH minus. Therefore, here the total OH minus will be is equal to 10 raised to power minus 8 plus 10 raised to power minus 7. Take 10 raised to power minus 7 common. So, it will be 10 plus 1. That is 11 into 10 raised to power minus 7. This is the total OH minus which is coming into the solution. So you need to remember, if the solution is very, very dilute, then we have to consider the OH minus which is coming from water as well, because there is a lot of water And also NaOH, it is a strong base, so the pH cannot come below 7. So if you are getting the pH below 7, then you need to understand that we have to take the OH minus coming from water. Now let us see what is the pH of this solution. So we got the total OH minus concentration. Therefore now POH is equal to minus logarithm of OH minus concentration, which is minus log to the base 10, 11 into 10 raised to power minus 7. So this is minus log to the base 10, 11 minus log to the base 10, 10 raised to power minus 7. The value of log 11 is 1.04 and this will be minus of minus 7, minus 1.04 plus 7. Now you subtract 7 minus 1.04, which is giving you 6.96. This is the POH. Now we have pH plus POH is equal to 14. Therefore, pH is equal to 14 minus POH. The value of POH is 6.96. 14 minus 6.96, which is giving you 7.04. See, the solution, the pH of the solution is more than 7. It is almost, neutral, because it is a very, very weakly alkaline solution, but still we are getting the pH more than 7. So in today's video we have seen how to solve the numerical based on the pH of weak acid and pH of bases. Okay. So now in the next lecture we are going to go ahead with the common ion effect. Next lecture will be on common ion effect, and then we are going to cover buffer solution. So till then, study well. Thank you so much.